Question 1. A cube of volume V is placed in a liquid of density ρ. The cube displaces weight of the liquid. Which of the following gives the magnitude of the upthrust acting on the cube? This question can be answered easily with the theory. According to Archimedes' theorem, upthrust acting on an object is equal to the weight of the displaced fluid. So the question, it says that weight of the displaced fluid is W. Therefore, upthrust is given by W. Answer should be D. Question 2. A seesaw is a uniform beam that balances on a support. The beam can rotate around the top of the support. Two children of equal weight sit on a seesaw at equal distances from the support as shown. Which row of the table describes the resultant force and the resultant moment on the beam? As you can see, the beam is stationary. It doesn't move vertically upward or vertically downward, or it doesn't move in horizontal direction. Therefore, the resultant force on the beam is 0. According to the question, they say that two children of equal weight sit on the seesaw at equal distances. Therefore, the moment produced by the weight of each student will be equal and opposite in direction. Student on the left side will create a moment in the anti-clockwise direction. Student on the right side will create a moment in the clockwise direction. Since the two moments are equal and opposite in direction, the resultant moment is also 0. So the answer should be option A. Third question. The diagram shows a ball of mass m moving at speed v along a horizontal table. The ball leaves the table. The time taken between the ball leaving the table and landing on the floor is t. A second ball of mass 2m moves at speed 2v along the table. Which of the following gives the time taken between the second ball leaving the table and landing on the floor? This problem can be easily answered by considering the equations of motion, but you don't have to actually apply the equations of motion. You have to understand the concepts of the equations of the motion. If you look at the vertical motion of the ball, both the balls fall through the same vertical distance. And also, both the balls falls under constant gravitational acceleration. Initial vertical velocity of both balls is 0. Therefore, according to S equals ut plus half at squared, you don't have to do any calculation, but I'm just showing you the equation. Since they have the same height, initial velocity is 0, so you get half gt squared. According to the equation, you can see the time for the second ball should also be t. So the answer should be option B. Fourth question. The forces acting on a person sitting on a chair are weight and normal contact force. So here we have a chair, here we have a person, weight and contact force. Which of the following gives a reason why these forces do not form a Newton's third law pair? You have to remember that according to Newton's third law pair, there are 5 properties where the two forces must satisfy. The two forces should be equal in magnitude, they should be opposite in direction, they should be of the same type, they should act on different bodies and act along the same line of action. In this problem, contact reaction force and the weight both act on the same object. Therefore, they do not form a Newton's third law pair. So the answer is option C. Let's move on to question 5. A wire is to hang a picture from a hook on a wall. The wire exerts forces T1 and T2 on the picture. The picture has weight W as shown. Which of the following describes the relationship between forces when the picture is hanging on the wall? So, in this problem, vectors or the resultant force on the picture is 0 since it's hanging stationary. For the resultant, in order for the resultant force to be 0, when we think of the vector addition, if you consider just vector weight, like weight and tensions as the vectors, simply they are vector addition. You add the vector W, vector T1 and vector T2, and their addition should be equal to 0.